Here's a problem from homework number 13. It says when someone buys a ticket for an airline flight, there is a 0.0982 probability that that person will not show up for the flight. A certain jet can seat 14 passengers. Is it wise to book 16 passengers for a flight on the jet? Explain. All right, so let's go ahead and set up a probability distribution table. We won't fill in the whole thing, but it can help us see things a little more clearly. When we have a binomial like this, there are four things we need to know. We need to know n, p, q, and x. All right, so before we do anything, let's define our discrete random variable. We have a couple of choices here. We can let x equal the number of people that will show up for a flight, or the number of people that will not show up for a flight. And it really doesn't matter, but because this is put in the form of person will not show up, and that's the probability we're given, I'm going to go ahead and make that our x. So this is going to be the number of people, so it's discrete, it's countable, it's finite, who do not show up. There are no shows. Okay? All right. Therefore, if that's our x, p and x are always going to go together. If this is the number of people who do not show up, then this is your success. Not showing up is actually your success. So p is always the probability of a success. So the question becomes, what is the probability that somebody will not show up? And sure enough, they give us that value of 0.0982. Now, if you recall, Q is always the complement of P. These are going to be the probability that somebody does show up. So the two together will always add up to 1. So you can just do that on your calculator. What is 1 minus 0.0982? And that value is 0.9018. So now we have our P and our Q. All right. The next thing we have to figure out are N and X. What are we trying to find the probability of? All right. Well, first of all, let's start here. What is all the possible outcomes of people who do not show up? Well, the question really is it wise to book 16 passengers? That's the question we're trying to answer. So let's take a look at what happens if we book 16 passengers. Well, if we book 16 passengers, it is possible that 0 of those people do not show up. In other words, all 16 of them do show up. There's a possibility that one person might not show up and the remaining 15 will show up. There's a possibility of 2 people not showing up and the remaining 14 will show up. There's a possibility 3 people won't show up and the remaining 13 will. And so on all the way down the line. So whenever we have a probability distribution, it's countable all the way down here to the end. We have the possibility that, for example, 15 people will not show up and 1 person shows up, or finally the last and very unlikely possibility, all 16 people that you book do not show up and 0 people show up. Okay? This helps our thinking, and then we're going to figure out what we need to find, which probabilities we need to find to answer this question. So over here we have now established that n in fact equals 16. Okay? So the last thing we have to do is figure out x. Well, we have to decide that based on what we want to figure out. We are asked, is it wise to book 16 passengers? Is it wise to book 16 passengers? Well, being wise means that you're not overbooked. You don't want to be overbooked. We've all been at the airport when something gets overbooked and they're asking people to please skip this flight and go on another one. So we're told that this flight can hold 14 passengers. All right, so when do we have a problem? Let's really think about that. Well, if 0 people do not show up, meaning everybody shows up, all 16 people, we have a problem. We have a problem right here. A problem right here. All right. Do we have a problem if we have one no-show? I believe we do, because if one person doesn't show up, that means the remaining 15 do, and we still have a problem. What about 2? If 2 people don't show up and the other 14 do, then we don't have a problem. We have enough seats for everybody. All right, so this is our line right here between a problem and no problem. Down here we have no problem, and up here we do have a problem. Okay, so what do we want to find the probability of? Well, I'm thinking that it's going to be a lot easier to find these 2 values than these remaining 14. So let's work that way. Let's find the probability that x equals 0 and the probability that x equals 1. We need to find 2 probabilities because that's where our problem is. We know that if we add up all 16 of these, we'll get 1. What we need to know is the sum of these 2 values right here. Okay? I'm going to change my color so that we can start plugging into that binomial formula. All right, so let's start right here with the probability that x equals 0. All right, we know we have to use the binomials. Probability that x equals 0 is going to equal to 16 choose 0 times the probability of p, which is 0.0982, 0982, and we want 0 of those times the probability 0.9018 to the power of 16. All right, in addition, plus we want to find the probability that x equals 1. Well, that's going to be 16 doesn't change, n choose x, now x is 1. We are going to have 1 no-show, 0.9082 to the power of 1, times 0.9018, the remaining 15 who do show up. All right, guys, you can try that on your calculator, or we can use technology. I'm going to go ahead and pull up a StatCrunch screen here. We're going to click on, down here, we're going to click on Stat. We're going to click on Calculators, and we're going to open up a binomial calculator. It's up here. All right, in this case, we know that n equals 16. We are given p is 0.982. And we want to find the probability. Let's just start with equality here. The probability that we have 0 no-shows. Let's see what that value is. 0.1913. Let's do 1913. All right. 0.1913. All right. Okay. It's just about a 19% chance every single person shows up. All right. Let's go back again to our binomial calculator, and I'm going to change this from x equals 0 to x equals 1. Probability that one person doesn't show up and the remaining 15 do. And here we have 0.3333. I'll carry it out that far. Okay, so 0.3333. All right, so about 33% of these will, probably 33% chance that these one person will be a no-show. All right, if we add these 2 together, you can already see it's a problem because we're well over our 5%. But if you go ahead and do that on your calculator, you will get 0.5246. So that's already about 52% chance that you will have 0 or 1 person no-show. So just answering the question, is it wise to book 16 passengers? Explain, and they'll give you reasons on the problem, but I think it's not wise to book. Your chances of having a problem are very high, over 50%. Just running back here to show you with StatCrunch, that down here, what's nice about the binomial calculator on StatCrunch is you actually can do an inequality. We could have put in what's the probability that x is less than or equal to 1. So that would include the 1 and the 0. And you can see here it matches up the 0.524. So really use technology to your advantage and to make things go a little faster. However, it is important to understand where these numbers come from and these formulas and be able to plug in the values. All right, give it a try. Good luck.